Hello everyone, this is Saminathan Raju and I'm going to go through something regarding FHIR. Okay, without any further ado, let's get going. What is FHIR? Right? Fast Healthcare Interoperability Resources. That's exactly what we call as FHIR. But before that, let's get into some introduction piece, right? And as trends in the healthcare industry move towards making the data malleable, right? And interoperability is rather used as a fancy term, right? And everyone talks about interoperability, right? So in its most basic form, refers to the ability for clinical systems to aggregate, normalize, and harmonize various data sources irrespective of the volume for some sort of consumption down the line. So this is exactly what the challenge that we had in the past. So I have point A and point B. Point A has got a different data feed. Point B has got a different data feed altogether. But can it be made in one form, say point C, so that it makes some sense? Both point A and point B make some sense. So it should be interoperable to each other, so that I can get data from various sources, not just from A and B to C, D, E, F. It could be numerous other sources, irrespective of the data volume, so that I could aggregate and then manage at one point. And here is exactly where we have a concept of FHIR, right? So let's jump in. FHIR, right? So it is an interoperability standard for electronic exchange of healthcare information, basically. So FHIR was developed by Health Level 7 International, in short, what we call as HL7. It's a non-profit organization accredited by the American National Standards Institute that develops and provides framework and standards for sharing, integration, and retrieval of clinical health data and other electronic health information. Okay, so now we know what the FHIR is. Let's get into it, why FHIR and its uses, right? So why FHIR is important, So as health and IT and electronic health record, in short EHR, continued to plagued by interoperability problems, FHIR emerged in 2014 as a draft standard for trial use to help IT developers to more quickly and easily build applications for EHRs and to exchange, retrieve data faster from applications. Another significant FHIR effort is SMART on FHIR, is based at Boston Children's Hospital and has also gained broad industry support. SMART on FHIR is a set of open specifications to integrate apps with EHRs, portals, health information exchanges, and other health IT systems, according to the organization. Another is HAPI FHIR, in short what we call as Happy FHIR, a new library for adding FHIR messaging to applications. It was developed at the University of Health Network in Ontario, Canada. Happy FHIR is open source and free to use. FHIR also defines a framework for extending and adapting resources, which can be read by any system, regardless of the way they were developed. Extension definitions can be retrieved using the same framework as retrieving other resources. Each resource carries human-readable text representation using HTML. Now let's quickly jump to what HL7 and FHIR is and what's the relation between these two. HL7 is about, as we discussed, moving data between two applications, and applications written by different vendors, and vendors created the applications in a workaround. This is exactly what HL7 is about in a nutshell, right? And FHIR is a draft of standard narrating formats of data and elements, also known as resources, and API to share health-related records of individuals like medication, diagnostic reports, and general health information of patients. It is created by the HL7 Standards Organization. It is based on resources that are modular component that can be mixed together to solve a clinic-related and administrative obstacles in a practical way. Sysgain is the best company in the industry in HL7 development integration solutions, with help of highly experienced and skilled developers. Sysgain develops unique feature with high security and best apps and software using the latest technologies in the market and in the recent trends in IT industry. As a standard was created by a clinical interface specialist, the first production-ready version, HL7v2, was built to address the needs of real-world clinical practices. The group dedicated to take an 80-20 approach, meaning they only defined 80% of the framework and left 20% to be customized by whoever would use it. This gave users and vendors a place to reflect on unique business and workflow rules. HL7 indeed to be vague initially because they had to be, they really have to get more people on board using the standard. The more flexible the standard, the easier it would be to adopt. As more vendors adopt HL7, the standards, the value to clinicians and technologies grew. In 1998, HL7 found their tipping point when enough vendors were obtained that it actually became advantageous to use. The practical solution created widespread adoption for HL7. Moreover, because HL7's goals of application uniqueness, it created significant challenges across the continuum of care. Let's quickly jump into what are the challenges that we would normally be facing. It's like a bottom-up approach. Development of standards typically begin with an enthusiastic group of volunteers. But until FHIR reaches a level of maturity, governments are not likely to write into regulation. Adoption is likely to be slower. HL7v3 was largely successful in Netherlands, Canada, and England as the standards was used to support interoperable electronic health record programs. The second challenge is investment in previous standards. Standards have been around for over 30 years, and many health providers have invested millions in funding and resources to develop their digital maturity. FHIR could disrupt interoperability programs where standards are already in place, delaying the realization of benefits. The third is potential threats for vendors. Some IT vendors could be threatened by FHIR's ability to shorten deployment times of major systems like a shared health record, which would in turn reduce revenues. Integration providers that promote speed and ease of deployment are actively encouraging FHIR adoption to support transformation. Fourth, lack of visible case studies. Health and care is historically a risk-averse industry, and a few health providers actively promote innovation. The HL7 FHIR community are very proactive in sharing best practice and FHIR in action. However, these examples are sometimes not promoted more widely outside the FHIR enthusiasts. Fifth is lack of ownership. Despite its rapid maturity, FHIR is reliant on a community of groups or teams developing it. The UK's Interpopen and France Interop Santé are examples of proactive groups that are developing FHIR standards for specific use cases, but a wider roadmap is not in place yet. Fast development, but how about fast deployment? Rapid and easy implementations are a key characteristics of FHIR. However, the standard and the projects it supports can only be deployed at a pace that each healthcare organization can manage. Many healthcare providers are not clear on the resources required for the development of messaging, terminologies, and interoperability standards. Changes in IT infrastructure are also required to include FHIR, whilst investment in ongoing maintenance, support, education, and training will be required. Seventh would be the strategic fit. Many healthcare IT teams are under enormous pressure to keep current systems performing and reacting to short-term challenges. Large IT strategies are being undertaken daily, but how does FHIR fit in? Many people associate FHIR with REST protocol and as a storage standard for databases. but there are many ways it can be used, such as documents, messaging, and services. Let's quickly jump to what FHIR resources are. Resources are the data packages used to send or retrieve data from any FHIR repository. Resources are meant to capture a meaningful amount of data. For example, this picture shows a resource, right? And it has metadata, narrative, extensions, elements, and everything. A data housed within resources is broken into 4 parts that we discussed: metadata, narrative, extension, and element. So element is exactly what we're going to go through next. Elements contains the structured data for the resources. And before we go on to the data types, let's quickly see the examples and non-examples. The first to your right, you see they are the valid examples. Administrative can be patient, organization, and location. So it should be precise and to the point. And when say gender, it's like way too small. And the electronic health record is too big because the electronic health record is an ocean by itself. So it wouldn't be a good candidate for a FHIR resource. Let's say you're talking about a blood pressure. No, you're talking again too granular. No, it's very specific and it wouldn't be a good FHIR resource example. But the columns that I specified at my left side, like administrative, under which we have patient, organization, and location, this becomes a good candidate for a FHIR resource. Likewise, clinical. We have care plan, family history, and allergy, and that put together would form a good FHIR resource. Infrastructure, under which we have document, conformance, and message profile. And they are the good candidate as well. And let's quickly jump to extensions and see what it has to offer. FHIR data types. So under extensions we have, extension is under elements, right? So one element can be either of a primary or of a complex type. So we have like many primary type elements like instant, time, date, daytime, Boolean, so many. They are the primitive types. And complex type elements are like either a range or a period or a money, the distance, signature. There are like multiple complex types, and FHIR database supports everything. Be it a primary or be it a complex type, it does support everything. And when you use FHIR API to query the data, it's going to get you the data of any of these kinds. That is exactly what we're going to go to next. FHIR API is called HAPI, right? And the URL is just right there. And it's an open source FHIR API. It's developed using Java. As we see, it is directly accessible on the browser. It gets a request and it gives you the data in the form of a JSON. Based on the input you specify, the answer you get. Of course, it provides a lot of filtering criteria for you if you really want to filter down your JSON format. And these are the references that I had referred. And thank you so much for the time. And I'm unable to continue all the other sections, the live walkthrough or a demo due to the lack of time, and I did not get time to complete that part. I'm really apologies for that. And I hope this was a nice presentation and look forward to an opportunity to see you again. Thank you.